Right, hello, year 12. Right, I'm on my iMac now. This is not a Chromebook, so because I wanted to show you this animation, which is a Java animation. We're going to have a play with this in the next lesson, I think, but this perfectly, I think, explains or helps explain the stopping potential and how photocells work. So let me quickly run you through this. Right. Okay, here's the plate here. I've got zinc. I've set it to zinc. We've got sodium, zinc, copper, platinum, calcium, and an unknown metal, right? But we know about zinc because we've seen that. There's the light coming in. So intensity is on maximum, but if we take the intensity down, as expected, less electrons, less photoelectrons are emitted until when the intensity is zero, we're getting zero photo emission because there's no photons, right? But let's keep it on maximum. Now, what you should notice is, as I explained in the previous video, there's a range of kinetic energies of the electrons. There's some really, really fast ones, there's some middle ones, and there's some really, really slow ones. Okay, and that's because of the energy levels in the zinc atoms. The energy level, the electrons in the higher energy levels are going to be escaping with the maximum kinetic energy. Okay, but we can have a play with the frequency. So obviously we're in the UV region of the spectrum, so that's when we're getting the photoelectric effect. But if we take it into visible, as expected, nothing. Okay, now we can find what is known as the threshold frequency. The threshold frequency is the frequency at which electrons are just emitted. So if we take the wavelength down, we turn the frequency up, so this is violet, we're just about to go into ultraviolet, still nothing, still nothing, still nothing, still nothing. Okay, but you have to go way into the UV, there you go, before electrons are just emitted. So that's pretty much at the threshold frequency. Okay, pretty much at the threshold frequency. Let's just almost right, there you go. So I've just got it. See, we're getting slow electrons. All right, so I think anything just below that frequency would be regarded as a threshold frequency. And you can change this. We can tweak this. So we can maybe go 285. Are we still getting electrons? Yes, we are. We could go 283. Are we still getting electrons? Yes, we are. We could go 280. Are we getting electrons? No, we're not. We're just getting one or two. Okay, so we're pretty much at the threshold frequency there. Now, let's go higher. So as we're getting lots and lots of electrons being emitted there. Right, now what is the stopping potential? This is what I really wanted to show you this animation for. Stopping potential is here. Here's the battery. Now we could have a positive potential difference where this plate is positive. That's just going to accelerate the electrons more. But if we make this side negative and this side positive, I'll just start on zero. Let's start on zero. There you go. Now notice what happens to the electrons when we start to increase the negative potential. What's happening there? Okay, what you should be seeing is it's slowing them down. Okay, this potential difference between the plates is removing the kinetic energy of the electrons and it's making them accelerate back again. Now if we increase the potential difference, see, we're still getting a current here, aren't we? Yeah, there's still the fastest electrons are still reaching this plate here. Okay, if we just take it up. Now, what's happened there? We've just hit the stopping potential. Okay, maybe I could go 1.1. Okay. Well, what was I on? I was at 1.2, wasn't I? Start again. So it's you increasing this potential until this current just becomes 0. So that we'll stick with that. So what we've done there, we've found that the stopping potential here is -1 volt. Now, what we can do, like I showed you in the previous video, we can use this value of Vs, to find the maximum kinetic energy of the electrons. Now, what you'll notice here is, see these electrons? They're not quite reaching, are they? Right? We want them to actually go all the way, because this potential difference is between the two plates. So I reckon we can go a bit lower. So let's go 0.9. Oh, there we go. Right, so just see those fastest electrons. It's those fastest electrons we're interested in. So they're just reaching the negative plate. So there you have it. I reckon 0.95, maybe. Just short. Are we going to get any electrons just reaching? See, the electrons are just falling short. Right. Maybe that will just get the electrons. See the fastest electrons now? We're getting closer. We're definitely getting closer. But 0.95. No, I was going the other way, wasn't I? 0.90. So electrons just reach. I'm going to go for 0.91. There you go. Those the fastest electrons are just touching, and then they're coming back. So that is definitely, there you go. There you have it. The stopping potential for zinc for this frequency. Okay. Obviously, if I take the frequency up, then this is not going to be the stopping potential anymore, is it? Let's take the frequency up. Then the electrons have much more kinetic energy, so we're getting a big current there, aren't we? Okay. So that's what stopping potential is. Right, just gone back to set it to 0 again. Now what you can see here is, okay, where was the threshold? Threshold frequency was around about here, was it? A bit higher. Now, what would you expect? Sodium. Now, sodium's a very reactive metal, isn't it? If it's a reactive metal, would you expect the work function to be higher or lower than zinc? Okay. Well, if sodium is a much more reactive metal, then it's going to have a smaller work function because it's very easy for the electrons in the outer shell to be removed. So look at this. We put that on sodium, then the same frequency, the same wavelength of light that couldn't do the photoelectric effect with zinc, does it like crazy with sodium, because those electrons, those top electrons, are really easy to remove, okay, for sodium. Let's go back to zinc. Right, so there you go. That's the frequency. That's given us a lot of photo emission, a lot of the photoelectric effect with zinc. What about platinum? Now, platinum is a very unreactive metal, so that means it's very difficult for platinum atoms to lose electrons. So as expected, if we put it on platinum, that same frequency that releases electrons from zinc does nothing with platinum. If we want to release electrons from platinum, we have to take the frequency right up. Okay, so that each photon has enough energy to pull an electron out of a platinum atom. So there you have it. you can have a play with this tomorrow, so you can look forward to that. Anyway, that is me just showing you what stopping potential is. I hope that makes sense. Thank you very much.